Okay, so today we're going to make sure we have this baby out because we're going to be using this quite a bit. We're going to be doing just converting of lengths today. And the first thing we're going to be using is just looking at the metric system. Now, all of these prefixes here, this is why the metric system exists. Here, I have them right here. Where'd you get one? Okay, cool. The metric system is the newest of all the measuring systems. The only people that do not use it is the US because they're very entrenched in their traditions. But if you think about the US military, all scientists, whatever, they use the metric system. And why is it so nice? Because it's all powers of 10, right? So they're always powers of 10. And the prefixes, do you see what page we're on? We're on the very first. I see some people are lost. The very first one. So you got to keep backing up. Back up a couple more pages. And we're starting the actual lesson that we were in the middle of before. There we go. So here's all the giga, mega, kilo, hecto, deca, and you may recognize all of these, right? These are the big ones we're going to be using. I lost my highlighter. We're going to be using kilo, hecta, deca, deci, centi, and milli. Okay, these are the big ones. Okay, now, the way that I remember these, now this one we're going to call basic, the middle one. Okay, so starts with a B. That's basic. That is, like if you look at, that's our like milligram, or sorry, that's our meter, our gram, our liter, and all of these build off it. So this is the decimeter, centimeter, millimeter. We go this way. This is the decameter, the hectometer, the kilometer. So what we're going to be doing is we're going to be taking and moving them from one unit to the other. So the way that I always remember this is kill him dead, but don't commit murder. Okay? Kill him dead, but don't commit murder. So this stands for kilo, hecta, deca, basic, deci, centi, and milli. Okay? So kill him dead, but don't commit murder. So when I do these, I actually write that down every time, but a little faster than that. So if that's something that when we start making our study sheet together, right, we want to have that down so we're remembering kind of all the prefixes. So kill him dead, but don't commit murder. Okay, now and then all of these, this is imperial to imperial, imperial to SI. Now SI stands for metric. Imperial is all of the US measurements, like inch, foot, yard, mile. Okay, those are all what we call imperial. So these here are all imperial. Now all of these are imperial. So one foot is 12 inches. 1 yard is 3 feet. 1 mile is 5,250. Now you do not have to memorize this stuff. This is all on your formula sheet. And then we have SI to metric, or to imperial, I should say. And again, these are all the imperial measurements. And we're going to get to those in a second. So let's just start off with doing metric to metric. Now metric to metric, we use this. Okay, we do not use our formula. We don't need to use our formula sheet for that. And we'll see how these go because these are nice. These are the nicest to work with. So let's go to the next page. And let's ignore all that stuff because this stuff makes it quite complicated for students. They do not like multiplying by 1 over 1,000, stuff like this. So I'm going to show you a nicer way to do this. Now, here do you see we're metric to metric. This is meters to centimeters. So what I want you to do underneath, I want you to go kill him dead, but don't commit murder. Okay, we want to write that out every time. KHDBDCM. Kill him dead, but don't commit murder. Now, it says we want to go from meters to centimeters. Now, where on here is meters? That's in the basic, because it has no prefix on it. That M stands for millimeters. Okay? So, we are right here. This is where we start. So I always want you to circle where we start. Now, are we going right or left to get to centimeters? Right. How many places? 1, 2. Now, all I have to do is now move the decimal 2 places. So I have this thing, a 1 here. But there's no decimal. How am I supposed to move it? But where's the decimal? It's right there, isn't it? Right? Every number has an invisible decimal, and that's where it is. And then what you do, we don't actually want to add zeros. You want to move it. So you go like this, 1, 2, and then you draw the decimal again. We're moving the decimal 2 to the right. So how many, like what do I do now? What do I do with these empty spots? Put zeros there. And then put centimeters. So 1 meter equals 100 centimeters. Okay, so now we're going to go from liters to milliliters. So again, I go kill him dead, but don't commit murder. Now we always want to circle where we are right now. Where are we? Which letter? B at basic. Now again, what are all our basics? B's will always be like meter, gram, liter. There's also like the Newton goes there. But those are going to be the big ones. So they don't have any prefixes on them. So we're here, and where are we going to go? We're going to go over to here, milliliters. So how many spots are we going to go? 1, 2, 3. So we go 1, 2, 3. Now, sometimes I'll get students that go, okay, so we just add on 3 zeros now. And that's not true. We don't want to add on 3 zeros. So write your number 2.3. And what we're going to do is we're going to take the decimal and move it 3 spots. 1, 2, 3. And then we draw our new decimal. And what do we put in those empty spots? Zeros. So 2.3 liters equals 2,300 milliliters. Okay, we want to do a couple more, so we're like practicing them. Again, it's metric to metric, so I'm just going to go like this. Kill him dead, but don't commit murder. Now we've got to figure out, where am I right now? Which letter? I'm at C. Very good. C for centimeter. See the C right here? That's where I know to go. That's where I'm starting. Where am I going to go to now? Which letter? B. I'm going to B. This is where I want to end up. So I have to go, take the decimal and move it 1, 2 to the left. So if I write 750 down, where's the decimal right now? It's right there, isn't it? That's where it is. Where's it going to go? 1, 2. So the answer would be 7.5 meters. So does everybody see what I did? I was here, and I went 1, 2. The decimal was here, 1, 2. So when we do these, we're only moving decimals. And when we move to the right and there's nothing there, we'll put zeros. Okay, this is another metric one. So 72350. Well, we got to write this down. Kill him dead, but don't commit murder. Okay, now the big thing is, where are we starting? We're starting at M. So let's circle M. So we know where we're starting. Now where are we going? Which letter? Okay, so how many spots is that? 1, 2, 3, 4, 5, 6. Now here's our number right now, and the decimal's there. That's where it's starting. And I'm going to move it to the left. 1, 2, 3, 4, 5, 6. So what am I supposed to put here in this empty space? A 0. And we always want to put a 0 in front of the decimal. Okay? So my answer is 0.072350 kilograms. Okay? Does that make sense? We'll practice a few. And okay, now the next thing is converting. So you can see now we have feet and we got centimeters going out. Now feet is American, or Imperial we call it. So I need to go from, I know that I'm going to be going from Imperial metric, because I got metric here and Imperial. Now again, it's always fun reading this stuff. So I went to this, for those people that do not like reading problems, I went to this kind of thing on helping problem solving for students, and they have this. It's called 3 reads, and what you want to do with your students all the time, and you want students to do, is always do 3 reads. The first read is just read it over once and see what the question's about. That's it. Okay? So we've got Sideshow Collectibles, it's a store, is considering making a statue of a dinosaur. They're considering a scale whereby 1 centimeter equals 2.1 feet. The height of the statue of the dinosaur will be 12.5 centimeters long. What would be the actual height of the dinosaur? So the first read, we're just going to go, okay, this is about, they're making a model, they're making a statue of a dinosaur. Okay? Now, then we read it one more time, because sometimes we want to get into it too fast and we just want to find information, slap it down, and see what we get. But let's first go, okay, we figured out that it is about making a statue of a dinosaur. Now, this Sideshow Collectibles is considered making a statue of a dinosaur. They're considering a scale whereby 1 centimeter represents 2.1 feet. The height of the statue of the dinosaur will be 12.5 centimeters. What is the actual height of the dinosaur? So the second thing we're supposed to do is, what are they looking for? And after the second read, I could say that we're looking for this. What is the actual height of the dinosaur? Okay. And then your third read is go find information to find that. Now they're considering a scale whereby 1 centimeter represents 2.1 feet. So let's write that. 1 centimeter equals 2.1 feet. And we can just use the FT for feet. Okay. So we're going to make we're going to make this equal. It says the height of the statue of the dinosaur will be 12.5 centimeters. what would be the actual height of the dinosaur? So we have to like figure out where to put the 12.5 centimeters. Should we put it on the top or on the bottom? Top or bottom? Got a 50-50 chance. Which one? Top. Why? Yeah, if there's centimeters here, we want to put centimeters here. That's what's called when we do them in ratio to each other. So we go 12.5 centimeters here. And this would be my x. Now, how do you find x? Because this is where, in fact, when x is down here is where students make the most mistakes. Now, to find x, there's two things we need. It has to be alone, and it has to be on top. It fails both of those right now. It is not alone. It's got this 12.5 thing on top of it, and it's not on top. Now, whenever you have two fractions equaling each other, you can take the escalator at all times, and it's all right. So an escalator means that we're not taking the elevator. You can never take the elevator. You just can't go switch these two. You can't do that. But what you can do is you can bring this up here, and you can actually just trade these two. So what happens is the x would come up top. We would have 2.1 times 12.5 all over 1. Now, I do want to show you something kind of cool, actually. Let's put the units in. 12.5 or 2.1 feet. And 12.5 centimeters. And then this is 1 centimeters. Now, just looking at the units alone, do you see how there's a centimeters on the top and centimeters on the bottom? They actually cancel. And you see the only unit left with is feet. And that's the unit we want, the actual height, because the actual height, 1 centimeter, this is the little model. Now, how would you put this into your calculator? Okay, because this one's nice, we just have to go 2.1 times 12.5. 2.1 times 12.5. And we get 26.25. Now, what would be the units? X would equal 26.25 feet. So we would say the dinosaur is 26.25 feet tall. So I just went 2.1 times 12.5. So right there. So ignore this part. Good, still recording. Okay. Now, use proportional reasoning or proportions. These are called proportions. When you make them equal each other, they're proportions. I'm going to show you another way to do it that you don't make them equal each other. You do unit cancellation. So, use proportional reasoning to convert 0.5 miles to inches. Now, if we don't know what it is, we can just call it x inches. So 0.05 miles over x inches equals. So this is proportional reasoning when you make one fraction equal another fraction. Now, go to your formula sheet, and where is there feet and inches on your formula sheet? Everybody have a look. Which one would you pick? So we're looking at this chart right up here. Is there anyone that helps us there? 1 foot equals 12 inches. Okay, so on our formula sheet it says 1 foot equals 12 inches. Now we have to put that over here. See where I just said, where are we going to put the 12 feet? Or no, we're doing miles, so we don't want to even use that one. Bad. What do we want to use? Which one? We got to go miles to feet. So we can't even get this directly to inches, can we? Okay? So, why don't we change this now? Let's find x feet because our formula sheet does not have miles to inches. So I know 1 mile equals 5,280 feet. So how am I going to put this in here? I'm going to put this either the top or bottom or this on the top or bottom. Which one should I pick to go on top? Which one should go here out of this? Which one? Should I put the feet up here? Remember when we're doing these, we want the units the same. So we'll put 1 mile over 5,280 feet. So when you make them equal each other, they always have to be the same top and bottom. Okay? Now now what's wrong with this? There's 2 things wrong. It's on the bottom and it's not alone. But these 2 could trade and this one could just come up here. So we'd have 0.05 miles times 5,280 feet all over 1 mile equals x feet. And do you see how miles would cancel? And we're just left with feet, so that would be good. Now how would I put this in my calculator? What would I put in my calculator to be able to get the answer here? 0.05 5,280 feet. And that would be 264 feet. And I've done all that work, and I'm still not done. Why? I got to convert it to inches. So we got to do it one more time. So now we can do it the way we want. We could put, I'm going to put x inches on top over 264 feet equals, what should I make it equal? Go to your chart, 12 inches over 1 foot. And do you see how I have feet both on the bottom and inches both on the top? Now, is x on top? See, this is a good thing, 1, but it's not alone. So take this and move it up the escalator. And then x would equal 12 inches times 264 feet all over 1 foot. And you see how the feet cancel because one's on top, one's on the bottom. So I just have to put in 12 times 264. Move this over here. So 12 times 264 equals 3,168. What would be the units? See how I just have inches left? So that would be 3,000, forget what I get, 3,168 inches. Now this is one way to do these. There's another way to do them, and it's by using unit cancellation, which I prefer. I teach it both ways because some students like this, where they make them equal each other and then they take the escalator. This way I'm going to show you is we're just going to keep timesing until we get the right answer. Now that sounds a little bit random, but we're going to do this one here. So we're going to take, and we're going to do it a different way. We're going to go 0.05 miles to inches. So we're going to do example 4 right now. 0.05 miles to inches. Okay, so what I do is I write 0.05 miles. And at the end of the day, at the end of the rainbow over here, I want it in inches. Now I'm going to multiply by something on my, so see, I'm not making them equal. I'm multiplying by something on here that'll help me get to inches by the end. Now there isn't miles to inches, but there is miles to feet. Okay? So, and I don't want you to write this down. I want you to just look up here. Okay? I'm going to go miles to feet. So, 1 mile is 5,280 feet. Don't write this down because I'm actually doing it wrong. Now, this is true. 1 mile is 5,280 feet. But what's going to happen when I take miles and multiply by miles? I'm going to get miles squared over feet. I want to get miles on the bottom, so the miles and miles cancel, and I'm just left with feet. Okay? Students sometimes just put it down. I go, but that's not, they're not going to cancel. And they go, what are you talking about? I don't know what you mean by cancel. Okay? Like whenever you have a an x, y over x, the x's cancel. Okay? Whenever there's something same on the top and the bottom. So I know that this won't work, so then I have to move it around. So I'm going to say 1 mile is, I'm going to go back, 5,280 feet. Now there's a long line there actually, and do you see how we have a mile here and a mile here, and we're only left with feet as my units. So now I just have to take 0.05 and multiply by 5,280, just like I would just going along, right? So 0.05 times 5,280. That's 264 feet. I still am not there yet. Inches. Now if we go here, it says 1 foot equals 12 inches. So I'm multiplying that by 1 foot over 12 inches. Now where should the feet go? Where should the inches go? The feet should go on the bottom. And make sure this is true. Is 12 inches 1 foot? Yes, it's true. Like don't put 14 inches over 1 foot and then expect to get the right answer. Because 14 inches isn't 1 foot, right? So we got to get this off our chart. And then always do this. Make sure those cancel. And then you just have to go and do clear 264 times 12, and I get 3,168 inches. And you see that I should have inches left because that's what's on top by itself. So I did B actually, showing by cancellation of units. I really like cancellation of units so students know why they're doing it. If they skip the Y, then they'll put anything here. They'll put 1 foot over 12 inches, they'll multiply it, and they don't know why they got it wrong. And that's frustrating. Okay? If you're a golfer and you're always shanking it into the bush, it gets very frustrating. And you don't know why, and you don't know how to fix it, right? And sometimes when you have somebody with you that's really good at golf, all you have to do is stand differently, keep your head down, and look at the ball. You do that, and all of a sudden you get a good swing. You feel a little better about the game. But time after time after time, if you're doing something wrong and you don't know why, basically you want to give up golfing. Okay? Now, what we're going to do is one more, and we'll see how this goes. Okay? So we're taking 75 meters per second and changing it to kilometers per minute. Now, this one, do you see how we have to change first from meters to kilometers? So what should we be using? We're doing metric. What do we use? These are both metric. Good, very good. We use kill him dead, but don't commit murder. Let's first get this to kilometers. So right now, we have 75 meters. We're right here. We're going to start at B, and we're going to go to K. We're going to go 1, 2, 3. Okay, so my 75 is here, and I'm going to go 1, 2, 3. So 0.05 kilometers, or 0.075 kilometers. Okay. So we took 75 meters and turned it into kilometers. So now we have 0.075 kilometers per second. Now all we have to do is change this. We're going to multiply this by something. So we get kilometers per second. So what should I be multiplying by to get kilometers? No, I want kilometers per minute. My bad. I want kilometers per minute. Sixty seconds is 1 minute. Okay, so we know that. 60 seconds is 1 minute. How am I going to put it here? What should go on top? That's a good question, eh? What should go on top? The 1 minute? Should I go 1 minute over 60 seconds? Why not? Why? I need to know why, though. It won't cancel out. I'm going to have seconds squared on the bottom, won't I? Right? So we go 60 seconds up top and minutes on the bottom. And then we cancel the seconds. And then we just have to go 0.075, 0.075 times 60. And we get 4.5 kilometers per minute. Must be a rocket. But that's good that you can even identify that that's a lot in 60 seconds, right? So right now you've just been watching me and you're probably kind of a little fuzzy on it, right? So what we want to do is so we're going to be doing 1 to 6, and for each do A, C, E, G. And let me look at, I have question 13, but I thought we did 13 yesterday. Oh yeah, we did 14 yesterday, yeah, so and 13. Okay, now I'm going to stop my recording.